So this is the fourth video for the OCR B1 21st Century Science revision, and in the last clip I set you a problem of completing a Punnett square diagram for the following situation for cystic fibrosis, which was that one parent was capital F, the other parent was big F, little f. So let's see what happened in this situation. So that's one parent at the top, and then the other parent there. So in this case, we've got big F, big F, big F, big F, little f, and big F, little f. So, so the answer here would be that there would be two possible of the four where the offspring would be a carrier. So a 50% chance of being a carrier and a 50% chance of them being not. There's a 0% chance of the offspring actually getting getting cystic fibrosis. So 0% chance of getting CF. And the other problem I set was if one parent was little f, and the other parent was large f. So this parent has cystic fibrosis and this person does not. So little f, big F, big F. Let's see what we get. So big F, little f, big F, little f, big F, little f, big F, little f. So in this case, in every single of the four chances, the offspring will be a carrier. So 100% chance of being a carrier. So that offspring will have the cystic fibrosis recessive allele. But the chance of having the disease itself, the disorder, is again 0% chance. None of those offspring will get cystic fibrosis. Hopefully that matches your answers too. So let's have a look then at my second genetic disorder, which is Huntingdons disease or disorder. So in this case, in Huntington's, Huntington's is a faulty allele which is dominant. So we'll just call that H for short. So H is a faulty dominant allele. And so Huntington's disorder, HD. So in Huntington's disorder, what happens is you have to have, so symptoms are increasing loss of muscle control, which normally comes on in middle age, and forgetfulness, and loss of understanding. So a degenerative disease, often leading to unfortunately an early death. So let's have a look how it plays out in terms of genetics. So as we said, it's a dominant allele, so it's going to have a capital letter, and in this case, if you are heterozygous, so if you have the dominant and the recessive, then that means you will have Huntington's disease. If you have HH, then it's the same, you will have Huntington's disease. So the only time that you don't get it is if you have the two recessive alleles, which means you will not have Huntington's disorder. So, using your knowledge of Punnett squares, why don't you try out the following Punnett squares? Let's imagine that one parent has Huntington's disorder and the other parent does not. So I want to know is what is the percentage chance of the offspring, in this case, of the offspring having Huntington's disorder, and number two, what is the likelihood in this case? So 2 to try, 2 Punnett squares to make.